In this video, we're going to take a look at the 2015 Paper 1 sample that was released, and it's question 1, and this is taken from StudyClix. So it says that the sets U, P, Q and R are as shown in the Venn diagram. So U is the universal set. It then says, use the Venn diagram to list the elements of. So to show that it's a set, I'm going to use braces here. And it's saying P union Q. So that is everything in the circle or set that represents P. And then everything that's also in the circle Q. And it's a union, which, as I would have said when we looked at this the first time, I would have said it's like the marriage between the two. So you're going to put everything together. So they'll get 1, 2, 4, 5, 3 and 6. They don't need to be in order, but what you need to watch out for is that you're not repeating elements. You can't repeat elements in a set. The next one is the intersection. So the intersection between Q and R. So this is the circle Q. And where does that overlap with R? That's in this region here. So where are there numbers that belong to each one? So you've got this section. And you're going to then have simply two elements, 5 and 6. The next one, P union with Q intersection R. What I'm going to have for this one is we take all of P and the intersection of Q and R. So all of P is going to be 1, 2, 4, 5. So 1, 2, 4, 5, all within the circle P. Then we also take Q intersection R, which was this region here. I already have the 5, so I just need the 6. So that's our list of our elements. Let's keep going. The next one is a bit of a step up now. So Miriam says for all sets, the union is distributive over the intersection. Name a set that you would use along with P union with Q intersection R to show that her claim is true. So if she's showing that it distributes across, what we have is that we want to show that P union with Q intersection R, that's the same thing as if we did P union with Q, and then we did that intersecting with P union with R. So it's like your brackets when you'd multiply them, P union Q and P union R, and then you want to get the intersection between them. So it's exactly like what we have the distributive law when it comes to multiplication. So let's see if that's true. P union Q, if we listed those elements out there, we have them here, look. 1, 2, 4, 5, 3, 6. We then want to list the elements of P union with R. So if we go back up, we've got 1, 2, 4, 5, 7, 6. So we have 1, 2, 4, 5, 7, 6 is what we had. If we look for this now, what's the intersection? So the intersection of them are the elements that they have in common. So both of them have 1, both of them have 2, both of them have 4, both have 5, both have 6. So if I write out that, then the intersection of them is 1, 2, 4, 5, 6. What did we have when we did this? Have a look. We have it up here. They're equal to each other. Look, 1, 2, 4, 5, 6. And they do equal to each other. So by using that, we can say that they distribute over each other. So you just have to write a concluding statement to say, since they are equal, Miriam's statement is true. The union is distributive over the intersection. So it distributes P union Q, P union R. So that's the 2015 sample question. Let's take a look at another one now from 2015. So this is 2015 and it is paper 1, section 1, question 1. And this one that we're looking at is asking us first to complete the Venn diagram. So the Venn diagram asks us to have set A to include 1, 2, 3, 5, 6, 7, B is going to be 2, 3, 4, 5, 8, 9, and C is 1, 4, 5, 10. So 1 belongs only to A. So I'm going to put a dot and I'm going to put it in A. 2 belongs to A and 2. So I'm going to put it in here. 3 belongs to A and B. So 3 belongs to A and B, which means I'm going to put it in here. 5 belongs into A, B, and C if I take a look there. Oh, my incorrect error. 1 doesn't belong if I took a look properly. 1 belongs to A and C. So actually 1 should go there. The next thing, I've done 1, 2, 3, 5. Then we're going to look for 6. 6 belongs to just A. It's not listed in B. It's not listed in C. So I'll put 6 just in there. And then 7, does it belong to any of the others? No, it doesn't. So I've done all of A. Let's look at B. I have 2, 3. 4 hasn't been placed yet. But if I look at 4, 4 belongs to both B and C. So I can put that in here. Then I'm going to have the next one is 5. Element 5, it's already placed. So he's done. Element 8, it only belongs in set B. And then element 9 also only belongs in B. For set C, I've already placed 1 and I have placed 4 and 5. So the last one I need to place then is element 10. So there I have my set and Venn diagram filled in from the sets that they gave us. They then want us to talk about listing the elements of A union B. So again, that's when the two sets form a union together. It's basically like a marriage. They get everything and they pool it all together. So we're going to have 1, 2, 3 for sure. So 1, 2, 3. 4 because it's in B as well. We'll have 5. We will have 6. We will have 7. We will have 8 and we will have 9. So all of those together, the only number we're missing is 10 because it doesn't belong to A or B. What about A take out C then? So you need to think about, right, let's look at everything in the set A. Imagine I came along then with a rubber and I rubbed out everything that's also in C. Well, that takes out 1 and 5. So we're then left with 6, 7, 2, 3. And they don't have to be in order, but I'm just going to list them in order. The next one then is A union with B intersection C. So we're going to have A union B intersection C, which is going to be all of A married with B intersection C, which is this region here. So I'm going to have that it's going to be, let's see, 1, 2, 3, 4, 5, 6, 7. Because it's all of A and this intersection. So it's 1 to 7 inclusive. So we're going to write that. So it'll go 1, 2, 3, 4, 5, 6, 7. Now, that year there was also a question about asking us what is an equivalent set to this. So if I had A union B intersection C, what's that the same as? And what we actually need to remember is it's very similar to the question we did above, right? Very, very similar to this one. It distributes across. So remember that you can do P union Q and P union R, and the intersection of those will give you the exact same thing. So that's actually what this question is getting at. So we're going to have that it's the same thing as having A union B, the intersection of that with A union C, because the union distributes across the intersection. So we can simply write it like that. That was a tough enough question that on the spot you'd kind of have to think about, but if you just remember that it distributes, that factor or that feature is very important for us. The next one then is 2014 paper 1 section 1 question 3 part A. So looking at this again, we have been given a list of elements in the sets, and now what we need to do is we need to place them within the sets, just like we did before. So 2 belongs to A and B, so I'm going to put that in there. 3 belongs to A only, so I'm going to put that in there. And I'm using dots here to show that we're talking about elements. This 3 is not the cardinal number. This 3 represents that 3 belongs to A. The 4 then belongs to A, B, and C, so I'm going to put that right in the middle. 5 then is going to just belong to A. 6 belongs to A and B, so I'm going to pop that in the intersection there. 8 belongs to B and C, so it's going to go into the intersection here. 10 belongs only to B, so he's going to go into this region here. The number 1 belongs to C only. 4 has been placed. 8 has been placed. 12 belongs to C only. And then we have 14 also belongs to C only. So now we've them all placed, we can start to talk about this, the intersection. So what is the intersection of A and B? So what elements do they have in common? Well, they will have 2, 6, and 4 that exists within the circle of A and exists within the circle of B. So we're going to have 2, 3, and, 2, 4, and 6. What am I saying? 2, 4, and 6 that exist within the circle A and the circle B. B take out A intersection C. So if you have B, and then anytime there's an intersection of A and C, you take that out. So A and C intersect here, so I'm going to be taking that one out. So it leaves me with 2, 6, 8, and 10. So 2, 6, 8, and 10 is what we have for B. Take out that intersection. So 2, 6, 8, and 10. The next one then is B less A. So B take out A, union with B take out C. So what will that leave us with? So B take out A would leave us with, take out these ones, we'd be left with 10 and 8. Then we're going to combine that with B take out C. So we'd be taking out this and we would be taking out this. So what does that leave us with if I have the union of them? So the first one, when I did this, let's write it in 2 parts. So we're going to have, the first one worked out to be 10, 4, and 8, because I took out, 10 and 8 simply, because I took out all of the pink in the first one, because the pinks belonged to A. So I'm left with, for the first one, 10 and 8. Now, for the next one, what am I looking at? B, take out C. Well, for C, I'm saying take out the blues. So 10 is left, but so is 2 and 6. Now, the union of them is when you add all of the elements together. So you were going to add all of the elements together in one set. So we'll have 10, don't repeat it, just write 10 once. Then we'll have 8, we'll have 2, and we'll have 6. So sometimes I find that really helpful if you draw out the sets for yourself and just take your time. It then says write down a null set in terms of A, B, and C. Well, it's this guy here, isn't it? That set has no elements in it, so it's a null set. Now, how do I write that? How do I represent this region here? Well, this region here, it's a part of A if you take out, or you could say it's a part of C if you take out the A region. That's what we're talking about. Or if you have, let's say it's the intersection, would we say that? It's the intersection of A and C take out B. Wouldn't that get rid of that? So if I write that down, it's where A and C intersect. So it's really A and C where they intersect, but let's take out the third region where B overlaps. So again, what would that give me? A intersection C would give me this region here. And then if I want to just have that region here, what do I need to say I'm taking out? I want to say take out this region. Now what does that region have that this other blue section doesn't? That region has that it's also a part of B. So we have, if we have A intersection C, that's this I-shaped part, take out B, that gets rid of the red section, and we're just left with this region here. The next one is one of the tricky ones where they talk about maximizing and minimizing results. So this is a tricky kind of question. So it's 2014 paper 1 question 3. So in a table quiz, 100 questions were asked. Team M answered 72 questions correctly. Team N answered 38 questions correctly. Find, with the aid of the diagram, the minimum number of questions answered by both teams correctly. And it's then saying find, with the aid of a diagram, the maximum number of questions answered correctly. So what we need to be thinking about is, if they were looking for find, with the aid of the Venn diagram, the minimum number of questions answered correctly by both teams. So answered correctly by both teams means this one in the middle we're looking for. So that's the X that we're looking for. I then want to say, right, what does it mean? There's 100 questions. If there is 100 questions, but Team M answered 72 correctly. Team N answered 38 correctly. If I actually add those two together, I get 110. So what does that tell me? Well, it tells me that there has to be some overlap between them. At the very least, they have to have answered 10 both correctly at the same time. Because there's only 100 questions, when I add these two together, I see that there's a double up of 10. So that means that I can put 10 into this region here. So that would leave me with Team M would have 62 on its own correct. 10 questions they answered the same as Team N. And then 28 for Team N, because their full circle needs to represent 38. 10 and 28 is 38. So what's the minimum number of questions they had to have answered correctly? It's 10. Now, the next one is, what's the maximum that they will have gotten? Now, technically my Venn diagram isn't complete here until I filled in everything. So I added these two together. 62, 10 and 28. We know that now totals to 100, so that means that there was 0 on the outside, just to be sure that we're filling in the Venn diagram correctly. For this next one, it's the same question, but we're going in the other direction. What's the maximum number of questions that they both could have answered correctly? Well, the maximum number of questions is simply going to be if all of the questions that Team N answered correctly were the same ones that Team N answered correctly. So Team M has to total to 72, but I'm going to say, let's say that every single question that this team answered, let's assume that those were all also answered correctly by Team M. So let's say the 38 is in the overlap. Let's say they got no unique questions. Every question that they got right, the other team got right as well. So if that's 38, how do I get what's left over? Well, the total has to be 72. So we say 72 take away 38, which is 34. 34 goes in there, and then we must always make sure, is the universal set totaling to the correct amount? So it has to total to 100, which means that 34 and 38, which gives me 72. 72 plus 28 is what has to go here to give me a full total 100.